All right, so here we're going to be looking at patterns and linear functions. And we are going to be doing these mostly basically just on tables or t-charts. And we are doing the super simple ones. This video is just to get you warmed up, get you comfortable working with tables and writing and working with functions or equations. Okay, so here we go. So complete the table, and this is a review example here. So in order to find the value for this box here, we're looking for the y when the x is 0. So we're going to take our equation, this negative 2x plus 5, negative 2x plus 5, and instead of the x, we're going to replace it with what x is for this row here, and in this case, it's a 0. So we have negative 2 times 0 makes 0, plus 5 makes 5. So the value there is 5. Now we'll do this blank here. So on this blank here, the x is going to be a 1. So we're looking for the corresponding y. So we're going to take our equation here, negative 2x plus 5, and we're replacing the x with a 1, or replacing the 0 with a 1. So negative 2 times 1 is negative 2, plus 5 makes a positive 3. Next up for this one, we're going to put a 2 in for the x. So negative 2 times 2 is negative 4 plus 5, and we're just doing order of operations, makes a positive 1. And the last spot there, 3 goes in for the x. Negative 2 times 3 makes negative 6, plus 5 is going to make negative 1. And that's all there is to it for completing these tables. Now, the reason why we're reviewing this is so that way we can maybe come up with a shortcut. So when we have our x's that go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's actually a little bit easier, especially when we have a 0 in there. So the 0, that's going to be the start amount. So on our equation here, the start amount is going to be the number without the variable. So in this case here, it's a 5. So we're going to start with a 5. And then the coefficient, the number in front of the x, is telling us how much we are adding or subtracting for each one of these x's. So each one of these x's, we're going to subtract 2. So we're going to go 5 minus 2 minus 2 minus 2. So that's the shortcut, because in this video, we're actually going to be going backwards. We're going to have the t-chart or the table, and we're going to be writing the equation from the table. So we'll be working backwards. So with this here, if this was a word problem, we would say the rate is negative 2 and the start amount is a 5. And sometimes you can write this in reverse order, say 5 minus 2x if you want, and we'll get to that in the next page here. But that is a way of looking at it. This number that's all by itself, that's your start amount. And the coefficient, the number being multiplied to the x, tells you how much you're doing per 1x. So for every 1x, from 0 to 1, or 1 to 2, or 2 to 3, we're going to go down or subtract 2. So here we go. So we're going to write an equation from the relationship that's shown on this table here. So our start amount, we look for the 0. Now these ones, because they're the simpler ones, the 0 is going to be at the top for these ones in this video here. But if you don't have the 0 on the top, you have to go look for it. I mean, it's going to be one of these numbers down this column here anyhow. So you're just looking for that, and that the 0 is the start amount. So this is time 0, which is starting time. This is 1 second, 2 seconds, 3 seconds. If you're thinking time, and then this y, that's your money or your distance or whatever you might be measuring versus time there. So start amount is going to be, we look for when x is 0 and it's negative 2. So that's our start amount. Now we also look for the rate, or how much we're subtracting for each 1x. So x's go by 1s, the y's are going by how much? Well, negative 2 to 3, 3 to 8, 8 to 13, we're adding 5 each time. So we think of that as our rate. It's also going to be called slope as we get further along in these videos here. Okay, so now we're ready. We have our information. We're ready to write our equation. So y equals, so the y value here equals, and so we can do our start amount. So we're going to start at negative 2, and then for the negative 2, we are going to add how much? We're going to add 5. So we're going to add 5 for each what? 1, 2, 3. For each x, we add 5. So there we go. And again, the other way of writing it, and this bottom way here, this is a little bit more appropriate. This is, normally we write the variable term first, then the constant term. So this is kind of backwards here. They are mathematically equivalent. Now, if your teacher is saying, no, it has to be in slope-intercept form, that's this bottom one that they are asking for. But it's the same story here. So the y equals, well, it's 5 for every x. We're adding 5 for every x, starting at negative 2. okay, which is what was here. We add 5 for every 1x. See, the x's are going by ones, and that's important when you do these simple ones as well, starting at the -2. All right, here we go. Another example here. And in this case here, we're just writing the equation. Pause the video, give this one a try, and then come on back, see how you do. So here we're getting ready to write our equation here. So we do need to find start amount and rate. So start amount, remember, we're looking for the 0 on the x column there. So there it is. For these ones here, we're putting them at the top just to make it simple for you, but they could be anywhere in here. So we found our start amount. Next up, we do want to find our rate. So as long as the x's are going by ones, then you just look at the y's. So we're going from 5 to 2 to -1 to -4. We're subtracting 3 each time, or you could also say it's going down by 3. Remember, on all of these tables, we are reading them from top to bottom. You always read top to bottom for the tables. If you're reading it from bottom to top, it's called backwards. So don't do that unless you really know what you're doing here. Okay, so here we go. So we're going to start at 5. Right, 0 on the x gives us our start amount at 5. So 5, and then what are we going to do to that 5? Well, for every x, so we're going to subtract 3 for every 1x. So we went by 1x there, subtracted 3. Went by 1x there, subtracted 3. 1x there, subtracted 3. So that's what this is saying here. Again, it is more appropriate to write it this way, where you have the x term first and then the constant term second. But it's the same story here. So the y's are going to equal subtract 3 for every x starting at a +5. So again, basically what's going on here is you can take any of these x's here, and this gives you the formula to find the value on the y column. So you just take whatever x you might have at 4, 5, 12, 18, -11, whatever. Well, you take -3 times whatever that value for x is and then add 5. So this gives you the formula for going from the x column over to the y column there. So real quick, switching it up a little bit here, which table is linear? With the linear relationships, it's going to have a constant rate of change, okay? So if you notice, the x's are going up by the same amount. So again, we're doing the simple ones here. If these are changing, these go by 2's. But if it goes by like a 2 and then a 5 and then an 8 and then a -3, you got to work a different strategy here. But here the x's are going by the same amount. What are the y's going by? Well, -2 to 1, that's a +3. 1 to 4 +3, 4 to 7 +3, 7 to 10 +3. So as we read the table, again, from top to bottom, the y's are going up by 3 while the x's are going by 2's. All the x's are going by 2's, all the y's are going by 3's. So this has a constant rate. You're always adding 3 for every 2 x's here. So the rate is actually 3 over 2, 1.5, 1.5. So as long as you have a constant rate, that's going to be linear. Now let's look over here. X's are going by 2's. And let's look at the y's here. We're going from 4 to -3. Well, that's a down 7. And again, we're reading from top to bottom. 4 to -3, that's a down 7. -3 to -2, that's a +1. -2 to +1, that's a +3. 1 back down to 0, that's a -1. So here, the x's are going up by the same amount, but the y's, they're all over the place here. They're not constant. They're not doing the same thing. So when you don't have a constant rate, that means it's going to be a nonlinear function or nonlinear relationship or equation, depending on what you're looking at there. So here's all we're doing is we're looking at the pattern of the numbers, and we're just trying to decide if I have a constant rate, so I got to calculate that. It's going to be linear, and for your nonlinear ones, it's not going to be a constant rate. So the rates need to stay the same for linear functions. Okay, so real quick, wrap up here with these ones here. Got to identify the start amount, and that's we're looking for the 0 on the x column, and then you go over from there. It's the corresponding y as your start amount, so that's going to be a 5 for this one here. And then we need to find the rate. What are the y's going by per every 1x there? So in this case here, that was a down 3. So the y's equal, take -3, go down 3 or subtract 3 to each of them, starting at the 5, okay? And then your linear functions, that has a constant rate. Your not constant rates, those are going to be nonlinear functions here, and that's that example that we just finished up there.